of definite integral. This is the beginning of definite integral, and we are doing the definite integration by the technique of limit of a sum. As you all know that integration is just summation. Integrate means to sum. Suppose I have this function y is equal to fx, and I can plot the graph of this. This is fx and this is y on this axis. Here we have x, and we have to integrate this from, say, perform the integration fx dx from x is equal to a to x is equal to b. This is the value of the integral. This is having the limits, so this is definite integration, and you have to find this. Now what does this mean? This means that the area under this curve starting from x equal to a to x equal to b, this total we have to find. This is the meaning of this integration. So we can divide this into some small number of strips which are vertical strips, and you know that the area of such a strip, if we assume that this is a rectangle, is this height into breadth, and if we divide this total base, that is x equal to a to b, so this distance is equal to b minus a into some equal number of parts, say of equal width h. Then we have such n number of parts, and width of each is defined as h is equal to b minus a divided by n. And you find the area of one such strip, that is the length here, or the height multiplied by breadth, that is equal to h. Then you will be able to find the area of one such strip. So if I show it separately, it will look like this. The curve is like this. So this side is curved, but we assume this to be approximately a straight line. So the value of the base is h, whereas this is, here it is given by f. Suppose this point is x0, which is equal to a, and this is h, so this is x1, which is equal to a plus h. So here the value of function is fx0, and this is equal to f of a. Here it is f of x1, this is x1, which is equal. So if you find this area, so this is given by this length or the height, which is equal to fx0. So dA is the area of such strip. This is h. Similarly, the area of the next will be equal to f of a plus h multiplied by h, and so on. And then total area of such areas dA, and this is equal to first area h into fa plus second area h into f of a plus h. And suppose I divide this into n number of such parts, so this is plus h of f of nth one will be a plus n minus 1 into h. So this can be written in the form of integration, provided that the function is a continuous one. If the function is not continuous, I cannot write it in this way. Equal to a to suppose x equal to c, and then the function becomes like this. At x equal to c, the function is having some other definition. Suppose this point is x equal to b. So in this case, I will have to evaluate first from x equal to a to c to b, then the function is discontinuous. So this is this can be evaluated for a continuous function. So this is how you can write the total area of this. Now we divide this into such small number of parts, that is the number of rectangles we have drawn here, they tend to infinity. So h is b minus a divided by n, as you can see here, total number of divisions this. So as n tends to infinity, you can see obviously h tends towards 0. So the width or the breadth of such a rectangle is very small, and if you sum up all these areas, you will find the value of the integration. So I can write this integral y equal to fx, or this integral a to b fx dx in this term, the total area under this curve, and I can put the value of h here in this expression. So h is given by b minus a, and b minus a is a constant, so I can write this as summation of fa, and here I should write into 1 by n, where n tends towards infinity. Fa plus second term is f of a plus h, and so on. We will continue with this. Then f of a plus 2h, and n term is a plus n minus 1 into h. So friends, this will give you the area under this curve, which is nothing but the integration, assuming that the function is continuous, fx is continuous, and if it is continuous, then only you can evaluate this. So this is the value of h, b minus a divided by n, where n is tending towards infinity. So fa plus h you can find by putting the values of x equal to a, x equal to a plus h, and so on. And remember one thing here, that the variable, whether you put x, the variable f, you take fx, or whether you take ft, etc., this does not affect the integration. So this is the theory portion behind this. Now we can take a numerical here. The question is, this is a very simple question to begin. The integration is I is equal to 0 to 2 x square plus 1 dx. Now this is simple integration. You can do it by the conventional method also. So integral of x square is, that is x, limit is 0 to 2. Put the limits here, 8 by 3 plus 2, 14 by 3. This is the answer. So we can do this by this method of limit of sum. So here we have a is equal to 0 and a 0 and 2, b is equal to 2. Again we divide this 2 minus 0 by n, that is 2 by n, dividing this into n number of parts. So the value of h, the interval is, this is 2 by n, is given by 2 by n. As n tends towards infinity, h tends towards 0. So this integration can be written as is equal to b minus a divided by n, 2 by n, summation of fa. What is fa? The value of the function at a, x equal to a, that is at x equal to 0. So f0 plus, next is f of a plus h, f of 0 plus 2 by n, then next will be a plus 2h, and so on, and last is f of 0 plus n minus 1 into h 2 by n. So summation of all these terms, this will give you the value of this integration. So you will put the value here. So this is 2 by n summation, and remember that n is tending towards infinity. That is, we have divided the area under this curve into infinite number of such parts. So what is f0? If you put x equal to 0 in this expression, so I can write f0 is 0 plus 1, that is equal to 1. So 1 plus f of 2 by n. So in place of x, put 2 by n. 1 plus 2 by n whole square. And so next term will be f of 0 plus 2 into 2 by n, So similarly you can write the next term and then you can write the nth term. So in place of this x, you have to write here n minus 1 into 2 by n. So this is, so I can show here f n minus 1. So multiply this 2 inside, 2n minus 2 divided by n is 2n minus 2 by n whole square plus 1. Putting the value in this expression, so 2n minus 2 by n whole square plus 1. So you have 1 in every term. There are total n number of terms, 1, 2, 3 up to n. So we have 1 n times 1 plus 1 plus 1, this is n times. Plus on the other hand, I have term 2 by n whole square, then it will be 4 by n whole square and so on. So this term becomes up to 2n minus 2 by n whole square. So these are two series. We have to sum up simply. So this is n times 1 is n plus. Then next series I can take 2 by n whole square as common, 1 plus this is 4. So this is 2 square plus next is, so this is 1 square plus 2 square, and you can write the third term as equal to, sorry, this will be 2 square not 1 square, 2 by n square I have taken common. So here I can write, I should take 1 by n square not 2 by n square. So this is 2 square plus 4 square and up to n minus 2n minus 2 whole square. So we have to sum up these series. So this is n, and further you can write the sum of this series. So here we can write 2 by n sigma n tends towards infinity n plus 1 by n square, taking 2 square is common, 1 plus this will be 9 by 4, 2 square plus 3 square and so on up to n minus 1 whole square. Taking 2 out of this, this is n minus 1. So 2 square is common. So we have to write the value of the sum of the series, which is nothing but the square of first n minus 1 terms, natural numbers. So let me write this. By n sigma n tends towards infinity n plus 4 by n square into, I have to write the sum of this. The first term of such summation is, if I write 1 square plus 2 square plus up to n square, this is n plus 1, 2n plus 1 divided by 6. So here I am writing this for n minus 1 number of this up to square of n minus 1. So in place of n, write n minus 1. So first term is n minus 1, second is n, and third is 2n minus 1 divided by 6. So we have to simplify this now. So on simplification, this becomes If you multiply 1 by n inside, so 2 sigma and tending towards infinity. So 1 plus this n cancels this n, 1 by n and n, and 4 divided by n cube, n minus 1, n 2n minus 1 divided by 6. So 2 n tends towards infinity, 1 plus 4 by n square, this n cancels 1 n here, take n and n common out of these two, into n, 1 by n, 2 minus 1 by n, so this n square is also cancelled, 4 divided by 6. Now we can put n equal to infinity. So 1 plus the infinity here, this term is 0, similarly this term is 0. 2 by 3 into 1 into 2. So 2 into 1 plus 4 by 3. This is 14 by 3. So this is how you can solve this type of question. Now the reverse of this is also possible. The integration type problem can also be written in this form. Let me show you by taking one the entrance exam. The question is, we have to evaluate the limit, the sum of the series n tending to infinity 1 upon under root 4n square minus 1 plus 1 upon under root 4n square minus 2 square, this is 1 square, and up to n, 4n square minus n square. This you have to find. So this can be, if I take n square common out of all these, so when I take this outside, this will be n, and this is 4 minus 1 square over n square, plus second here 1 by n under root 4 minus 2 square by n square, and so on. This is n square by n square. Okay. Now here you have 1 by n square, 2 by 2 square by n square, 3 square, and up to n square by n square. So in the denominator, I can write, in the numerator I can write n square. So n is tending towards infinity, so this n can be taken as outside. So this is 1 by n, and n is tending towards infinity. Here I can write, in place of 1, 2, 3, etc., I can write this as equal to 4 minus r square by n square under root, where r is starting from summation of this, r is starting from 1 and going up to n, r is equal to 1 to n. So now this expression can also be written in the form of an integration. Starting from this, when r is equal to 1. Okay, so we have x is r by n, n is starting from 1, so it is equal to 1. And when n is infinity, then we have, what can be the limit? We can put the limit as equal to 0. The limit is 0. So this becomes, by putting the values here, under root 4 minus x square dx, and the limits are 0 to 1. when this is infinity 0 and 1 for 1. Now you sin inverse x by a here is 2, so sin inverse x by 2, 0 to 1. So sin inverse 1 by 2, pi by 6 minus 0, answer is pi by 6. This is how you can evaluate this integration.